Welcome back to ACER Explained. In this video series, I'm going through Section 3 of the ACER Practice Test Booklet. And in this video, I'm going through questions 58 to 61. So that's Unit 18. As usual, I'm identifying prerequisite knowledge, reasoning skills, and the bootcamp resources that can help with this. So for this stimulus, we're given a table. We're given a table with ciphers. So these are kind of codes to represent certain chemical structures. Then we're also given a structure in the next column. So I've just drawn those two out. And then we're also given a description there as well. And so we have some dot points underneath this table that says that some of these structures could be represented by multiple different ciphers. And then it says for those of the fragments that have square brackets around them, it says at the point of where that molecule attaches to the rest of the chain, it's designated as the first carbon of that fragment, or the first carbon of that fragment. So let's just look at question 58. Looking at question 58, it's asking us to figure out which of the following structures is represented by this following cipher. So C4.C3 2, 2. So looking at our table, let's figure out what this code actually means. So we have C4, right? And so this is in the description it says it's a 4-carbon chain. And so because there's that number 4, we can kind of assume that this chain is the one that it's referring to. It could also be this one here, but for the sake of just looking at one thing at a time, let's just pretend it's this one here. And then we have C1, which is another carbon chain that's attached. And then in the description, it says to the second carbon atom. So that explains this comma 2, right? So this little bit here, all right? Now, we have this particular cipher. And what we can kind of see from there is that there has to be a 4-carbon chain happening. And there's going to be a 3-carbon chain that's attached at the second carbon of this original chain, right? So looking at our answer options, we have 1, 2, 3, 4. So that sort of matches so far. And then we have a 1-carbon chain, so this is C1, attached to point 2. So this is not C3. There's no carbon chain that's 3 carbons long. It's C1. So this is incorrect. Then let's look at our answer option here. So we can look at our answer option B in terms of multiple ways. So we can do 1, 2, 3, 4, or we could do 1, 2, 3, 4. All right. So for now, let's do 1, 2, 3, 4. So this is our original chain. So this is our C4. And then we have a 1, 2, 3 attached here. So this is C3. And this is attached, however, at carbon number 1. Okay? So far, this is not looking like the correct option either. It's not attached at carbon number 2. It's attached at carbon number 1. And then here we just have 1, 2, 3, 4, 5. And so that's incorrect as well, right? That's not represented by C4 or C3. Then let's look at answer option D. So looking at answer option D, we can look at it in multiple ways, but in the way that matches the cipher that we're given, we can look at it like this: 1, 2, 3, 4, right? So that's our C4. And then at carbon number 2, we have 1, 2, and 3. So we have C3. And so this matches with our cipher, and so that's why D is the correct answer. Although at first sight this may look like a complicated chemistry problem, you actually don't need any previous knowledge here. It's all about finding the patterns and seeing what letter corresponds with what structure depending on the description that we see in the table. So all you need to be able to do is interpret a table and also find the patterns that you can use in order to answer that question. So the bootcamp resources that can help with this are the reasoning skills course, as well as the acceleration classes on tables and pattern recognition. So this question is asking us a similar thing. We are given a cipher here, and we're being asked which of the following structures corresponds to this cipher. All right, so we already know what C4 means, and we know what C1 means, and we know what comma 2 means. Comma 2 is talking about the position of C1 relative to C4, right? So now we've introduced A3 and these square brackets. So let's look at our table to figure out what A3 means. So over here we have A3, and in our description, we're told that this is a 3-carbon alkyl ring. So that's what A3 represents. And then we have a C1, which is a 1-carbon chain, attached at position 1. So let's look at the next bit where we're introduced to square brackets. So we have C4, which is a 4-carbon long chain here. And then at position 2, we have this chunk attached. So this is position 2, and we have this chunk attached. Now, what does this chunk consist of? It consists of an A3, which we know from earlier is a 3-carbon alkyl ring. And then at position 1 of this 3-carbon alkyl ring, we have a 1-carbon chain attached. Now, how do we know that this is position 1? Well, in the second dot point underneath our table, we're told that for bits with fragments or chunks within square brackets, that point of attachment, that's exactly where carbon 1 is. That's assigned as carbon 1. So that's how we know that that's the first position. And that's how we know that that's where this single carbon chain would be attached. So now let's take a look at our cipher that we're given. So we have C2. So this is a 2-carbon long chain, right? And then at position 1 of this chain, so that could be here or here. Let's just go with here for now. At this position, we have a chunk attached. And in this chunk, we have an A3. So that's our 3-carbon alkyl ring. So let's draw that out. We'll draw that out like this for now. Okay. And we also have a 3-carbon chain that's attached at position 1. So this is position 1, remember, of this alkyl group. We have a 3-carbon chain attached. So that's 1, 2, and 3. All right. So now let's compare and see how our answer options match up with this. All right. So looking at answer option A, we have a 2-carbon chain here, well, 1 and 2. Then we have this attached, then A3 attached, but we don't have that C3 attached at point 1. So we can eliminate this option at carbon 1. Now looking at B, option B, we have to identify a 2-carbon chain. So for this, it could be this. It could be this. So let's say that it's this. Well, this group here is attached at position 2, not at position 1, if we're looking at this. And also we have a random extra thing. So this actually wouldn't even be C2. This would be C4, right? So this is an incorrect option here. Now looking at option C, we have 1 and 2. So that's our C2. Then we have our A3 attached here. And coming off from position 1 of A3, we have 1, 2, 3, a 3-carbon chain. And so this matches the description of what we're looking for. So this is the correct option. And this last one simply does not have enough carbon. So we have our 2-carbon chain. Well, this is 1 and 2, and then we have our A3 attached, but nothing else. So that's incorrect as well. So that's how we can conclude that our answer is C. Again, this was the same reasoning as used in the previous question, so I won't go through this in much detail. Now, this is a bit of a different question here. It's asking which of the following structures has the lowest molecular weight. So what do we need to look for in terms of molecular weight? Well, we're looking for the types of atoms there are because each atom has a different molecular weight. And we're also looking for the number of atoms there are, okay? So we have two different notations here. We have C and we have A, okay? And so the A is representative of a ring and the C is representative of a carbon chain, okay? And so the A, we are told, because it's an alkyl chain, we have to use our chemistry knowledge, and we know that alkyl refers to a carbon chain. So the constituents of this ring is going to be carbon. And the constituents of this chain is also carbon, which we are told. Okay. And you actually don't even need to have that prereq knowledge to know that an alkyl chain is a carbon, because if you look at the third row of the table that we're given and the second row of the table that we're given, we're told it's a 3-carbon alkyl ring. So that's in the second row, right? And so we know that it's composed of carbon. So we don't even need to calculate the specific molecular weights. All we have to do is count the number of carbons, and whichever one has the most number of carbons is going to have the most molecular weight. Whichever one has the least number of carbons is going to have the lowest molecular weight. So over here we have 8 carbons. Over here we have 8 carbons as well. Over here we have 8 carbons as well, and over here we also have 8 carbons. Now we have to know the chemistry knowledge of the hydrogens. You have to know that there's going to be different amounts of or numbers of hydrogen atoms that are attached to each of your carbons. So now what we're going to do is draw these out. So I'm going to clear the screen here. So let's draw this one out. So we have 1, 2, 3, 4, 5. Okay, so we have our C5. Then we have a C1 at position 2. Then at position 3, we have a C1 as well. And then a C1 again at position 4. Okay, so we have carbon, carbon, carbon. Let's draw out all the carbons. Okay, so here you're going to have a H3 because carbons can form 4 bonds. H3, 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 and over here you're going to have 1 H each. Okay, so adding up the hydrogens, you have 1, 2, 3, 4, 5 times 3, or well, you also have 3 here, so 6 times 3 is 18 hydrogens. Then let's draw out B. So this was A. Let's draw out B. We have C4, so we're going to go 1, 2, 3, 4. So those are our carbons. Then at position 2, so at this position, we have a 4-carbon ring. So we can draw in our carbons now. So here we're going to have a H3 at the end. Here we're going to have a H2, a single H, and then we're going to have H2, 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 and a H. So now let's add up our hydrogens. So we have 3, 6, 8, 9, plus 1 is 10. And then we have 12, 14, 16. So we have 16 hydrogens here. Okay. Now let's look at answer option C. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then at position 3, you have 1, 2, 3. So drawing in our carbons once again, you have H3, H3, H2, H2, H, H2, H2, and H3. So now let's add up our hydrogens. So we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 15, and 18. So this is 18 hydrogens here. Then looking at answer option D, we just have 1, 2, 3, 4, 5, 6, 7, 8. So we have H3, then we have H2s along here. So we're going to get 6 plus 1, 2, 3, 4, 5, 6 times 2, which is 12. So you're going to get 18 H's here. So then the lowest out of these options is B, because it has the lowest number of hydrogens and they have the same number of carbons. So that's not going to contribute to the molecular weight. What's going to make the difference is the number of hydrogens. So for this question, you kind of needed to know the fact that, hydrogens are attached to those carbons. So you did need a little bit of that organic chemistry knowledge. But those are your basics. I would highly recommend that you're familiar with those. And the reasoning skills used, again, were the same as the ones from before. And this time we also used the process of elimination. And so the bootcamp resources that can help with this are the same ones as before, plus the bridging course on organic chemistry to brush up on some of that prerequisite knowledge. Question 61 is asking us to do something similar to what we did for that previous question, which was draw out the structure and then count the number of hydrogens. So we're given the cipher here. So let's go ahead and draw this out. So first of all, we have a 5-carbon ring. Okay. And then at position 2, let's say that this is position 2, we have a single carbon chain attached. Then at position 4, so let's go clockwise, so we have 3 and 4. We have at position 4, we have a 3-carbon chain attached. So we have 1, 2, 3. And then at position 5, we have a 5-carbon chain attached. So that's 1, 2, 3, 4, 5. And then I'm just going to reach over there. So 1, 2, 3, 4, 5. Okay, so at the end here, we're going to have 3 hydrogens, so H3. We're going to have 2 hydrogens here, 2 hydrogens here, 2, 2. We're going to have 1 hydrogen here. Over here, we're going to have 2 hydrogens, 1 here, 2 here, 1 here. And so what I'm doing is I'm just counting the number of bonds that are already attached to that carbon and doing 4 minus the number of bonds that are attached to that carbon. So for example, over here, there's 2 bonds already attached to this carbon. So out of 4, there's 2 more remaining that are going to attach to hydrogens. So putting a 2 here, and a 3 here, because 4 minus 1 is 3. And over here, we're also going to have a 3. Okay, so now what we have to do is we just have to add up the numbers. So we have 2, 4, 6, 8 plus 3 is 11. So I like to do things in little chunks to make life easier. And then we have 3, 5, 6, 8, 9, and 10. So we have 10 here. And then over here, we have 7. So just adding these up, we get 28 hydrogens in this structure. And so the answer that matches here is B. And for this question, it's exactly the same as the previous question. So that brings us to the end of this unit. Please like, share, and subscribe for more GAMSAT help. We really appreciate your feedback. We have our Instagram at Thank Flip GAMSAT, as well as our podcast, Thank Flip GAMSAT Nurses Doing GAMSAT, if you want to hear more from us. And I'll see you in the next one.